Hey all, thank you all that joined us. Maybe we'll get started in the next 30 seconds. For those who have joined, I am gonna be your MC and also one of the speaker right after Maxime. Um, Maxime is from Cohere and is gonna be talking about how we should be or how we should think about building flexible RAG, and we'll go into agentic workflow. For those who don't know who Maxime is, he is a senior product manager at Cohere, and he focuses on development of the Cohere's RAG tool usage and agents capability. So is all into developing that side of the LLM workflow. Um, he was also a product manager in a previous startup called Labelbox, which was a company for annotating data for AI. And he started in this field by doing AI research at Stanford back in 2016. So yeah, we have a very experienced a person with us talking about everything there's to know. RAG. Maxime, over to you.
All right, thank you for the intro, Ayush, and very excited to be here. Tiny bit of context around why weights and biases and Cohere we're presenting together today. We are building a RAG course together, weights and biases with Cohere and Weaviate, and you can sign up already to pre-register. And we are going to share just a few learnings today and a ton of learnings in that course that is coming soon.
Yeah.
Um, so yeah, super excited today to talk a little bit about how to build advanced RAG systems that work well in production. And this is based on a lot of our customers at Cohere. We build large language models that are focused on RAG and agents. And we try to share some of the best practices we're seeing in the field. So to get started, maybe starting with why. Why do we care about RAG? Well, RAG is, we care a lot about RAG because it's opening a ton of enterprise use cases. We are seeing every single company out there building some RAG systems. And the biggest use cases are number one, being able to chat with documents, especially very long reports, as a massive source of value. Number two, building knowledge assistants. And these knowledge assistants can be internal, like an internal HR bot that handles FAQs, or they can be external, like automating some customer support questions. Third use case is searching private data. And the fourth one is generating reports. And so these are all extremely valuable inside enterprises. And RAG is really helpful there because it goes beyond, it overcomes some limitations of large language models. And specifically, it allows systems to, it allows your chatbot or your assistant to access some private data. It allows it to access real-time data, which is extremely valuable. Because you provide some context to the large language model through RAG, it tends to hallucinate a bit less. And RAG is also, a key benefit is around RAG is really well set up to allocate access control, to do access control in the right way. So make sure that the end user has access to the data it should have access to, and no more. So RAG has been all the rage for the past 2 years, and the tricky part is it's really simple to get started with RAG. And usually the first version of RAG, simple RAG, naive RAG, starts a little bit like this, where you start in the bottom left with the user request. So typically user question for your chatbot, and you ask the model to transform that into a search query, which is going to tap into a vector database or an information retrieval system. And that search query is going to bring back some relevant text, some relevant chunks that are helpful to answer the user question. And the model is going to then generate a final answer based on, of course, the user question, but also the relevant texts that were retrieved from the vector database. And so it's relatively simple to get started with RAG. And one of the first things we learn when we get into production is RAG, simple RAG has a lot of limitations. And so my goal here is to describe a few of those limitations, the kind of questions that RAG systems tend to struggle with, and then how we see some customers go beyond that. How do they overcome those limitations? So first limitation we're seeing is that RAG systems really struggle when the answer is beyond a few chunks and requires understanding sort of the context of a document globally. And so a great example of that is summarization. If you put a RAG system in production and you ask, and a user comes in and asks to summarize the key points from a given report, it is with high confidence going to do poorly because it doesn't have, your RAG system is going to try to retrieve some specific chunks and it won't have an understanding of the document as a whole. So that's problematic for summarization, but it is also problematic for understanding. A lot of questions require understanding the document overall. For example, this question here. So that's the first limitation. We'll see how to overcome it. Second limitation is whenever the user comes in with questions that are about multiple documents. So for example, if you need to compare or cross-analyze multiple documents, RAG systems tend to do pretty poorly. So for example, here a user is asking, let's say you have two documents, a report about Google's AI strategy, and then a report about Microsoft's AI strategy. And the user comes in and asks, compare the two. In a naive RAG approach, in a simple RAG approach that we're looking at before, you'd sort of transform this into a search query, which would have, AI strategy, Microsoft, and Google inside it. And you would retrieve snippets that talk about, that sort of mention Google and Microsoft together. And they don't exist because you only have a Google report and a Microsoft report. And so here, to answer the question well, your RAG system needs to get a bit smarter and understand that it needs to retrieve the AI strategy from Google and then retrieve the AI strategy from Microsoft and only then compare the two. And so simple RAG systems really do poorly on these sort of cross-analysis questions. And same thing, we'll see how to go beyond that limitation. All right, limitation number 3. Simple RAG systems perform poorly when the user question requires analyzing complex data. So basically, RAG is great to operate on text, but in practice, in companies, a lot of data is just not text. It could be spreadsheets, it could be tabular data, it could be in databases, it could be in SaaS applications, like we have a ton of data in our CRM. That data is just very impossible for the RAG system to access. So like, if I ask a RAG system like, hey, here's the name of my table, what's the average sales volume for products? The RAG system struggles because this is not text data that it can retrieve from a vector database and then answer given the retrieved snippets. Same thing, we'll see how to go beyond that. And the last one I want to mention, which we're seeing a lot in production, is RAG systems might be able to answer simple questions, but then when you complexify the questions, it gets really challenging. So for example, in real life, most questions have multiple parts. They have many sub-questions inside them. So for example, what's the number of employees of NVIDIA, Microsoft, and Google? That's super, it looks like a super simple question, but there are in fact 3 sub-questions inside it. And same thing, your RAG system might, would take that question, try to transform it in a search query, retrieve chunks that mention NVIDIA and Microsoft and Google, but that's just not going to be helpful to answer to find the number of employees of each company individually. And a variant of complex questions that we're seeing a lot are sequential questions. And so, for example, what are the top 3 tech companies in terms of revenue, and how many employees do they have? This has two parts, like what are the top 3 tech companies and how many employees do they have? But these are sequential because you first need to find the top 3 companies before before knowing what companies, what employee number you're looking for. And so again, your RAG system would struggle a lot here because it cannot retrieve the employee number until it has actually figured out what were the top 3 tech companies in the first place. All right, so these are some limitations which we're seeing a lot of our customers bump into in production. And so what are some of these? In this section, we'll see how to overcome some of them with a slightly more advanced version of RAG. And my point here is to show that these versions of RAG are natural, like advanced RAG is really a natural extension from simple RAG. So first, let's look at these multi-part questions which are difficult. Like, what's the number of employees at NVIDIA, Microsoft, and Google? We're looking at it before. Your RAG system is going to struggle because if it transforms this user question into a single search query, it's going to retrieve chunks that mention NVIDIA and Microsoft and Google, and these chunks don't really exist. And so a very quick or a very simple extension you can make to your RAG system is called parallel queries, like allowing your LLM to produce not just one search query, but as many search queries as it wants, and therefore retrieve as many chunks as it wants in parallel from your information retrieval system. And so here, for example, you would have the model, the user comes in with this question around NVIDIA, Microsoft, Google, and the RAG system would say, we need to do 3 search queries in parallel, one for the number of employees at NVIDIA, one for the number of employees at Microsoft, and one for the number of employees at Google. And once you equip your LLM with the ability to do these queries in parallel, then it can actually find the right answer and answer this correctly. So parallel queries, first extension you can do, a very natural extension to simple RAG. Okay, number 2, RAG with tools. So far, we sort of assumed that our RAG setup was only connected to a vector database. And that's the case for most RAG systems. The idea here is to allow the model to retrieve from a vector database, but also from any tool it might want to retrieve information from. So for example, you can allow your model to retrieve from a spreadsheet if you connect the model to a Python console, because now the model can use the Python console to write some Python code and retrieve information from the spreadsheet. For example, using Python code to analyze the spreadsheet. Another example is if you equip your model, your RAG system with a search engine, like a web search engine, the model can now retrieve information from the internet. And so your RAG system can write queries that is going to tap into the search engine and retrieve information from the internet. Similarly, if you want to retrieve from APIs, you can ask the RAG system, you can equip your RAG system with the ability to create API queries, JSON queries, to retrieve from a SaaS application, like a CRM. And all of a sudden, your LLM is capable of retrieving not just from a vector database, but from any of your tools, which is extremely valuable because it opens up all these use cases, like what is the sales outlook for a product in my company? The LLM recognizes that to answer this, it needs to query Salesforce API or a spreadsheet or some other database. And now that the model is equipped not just with a vector database, but with a Python console or with the API, Salesforce or Oracle's API, it can actually retrieve the right information and provide the right answer to the user. All right, so how does that work under the hood? It is actually, again, a very natural extension to simple RAG, and that's the exciting part. It starts the same where you start with a user question, and this time you ask the model to generate not just a search query, but an entire tool call. So basically, the model will say, I want to call this tool with these parameters, and then you can go execute that tool. Again, not just a vector database, could be a web browser, a search engine, a Python console, a calculator, a calendar, whatever you want. This is going to give you some tool results. Could be the content of your CRM, could be some web content. And your model is going to use that to generate a final response. And so this gets very exciting because you unlock massive pools of data beyond just text. So let's look at that in practice. I'm asking the model, what are the rack system, what are the top 5 songs streamed on Spotify? And I give it access to a spreadsheet. The model recognizes that it needs to call a Python console. The model writes the Python code, and then that Python code gets executed. The results of the console are brought back to the model. And so your rack system is able to analyze that spreadsheet and provide the right answer, which would be completely impossible if it didn't have access to a tool like a Python interpreter or Python console. All right, last piece of improvement to your rack system that we're seeing companies adopt is this thing called agentic RAG. And so the idea here is that there are a lot of user questions which are sequential. We talked about that before. And so what if you could allow the model to make a plan before answering the user question? And so here, typically, before answering the user question, the model would describe the many steps it plans on taking in order to solve the request. And then you let the model do not just one step of reasoning, where it might call a few tools and answer. You actually let the model do as many steps of reasoning as it wants on a loop, iteratively. And after each of these steps, the model self-reflects and decides whether it wants to continue calling more tools in order to retrieve stuff, or if it can just answer the user question because it has enough information. And so this gets us in like agent territory, because now you have a model running on loop where it can decide to go on for as many steps as it wants in order to solve the user question. And this is really interesting because now the model can answer really complex sequential queries, which was not the case before. So what does that look like under the hood? And right after that, we'll get into the demo. So we'll see how this works in practice. Again, it's a natural extension. So you start with the user request in the bottom left. The question might be a bit complex and require many steps of reasoning. And the large language model is going to generate a plan around how to tackle that question. And it is going to start executing the first step of the plan. This is going to give it some tool results that the model will analyze, self-reflect, and decide that it needs to do a second step to answer the second part of the question. And then it is going to get some results based on that, and it is going to self-reflect, and it's going to keep going on like that step after step until it decides that given all the tool results so far, it has enough information, and the model can just provide the final response. And so that's sort of the most advanced version of RAG we're seeing in production today. And it is sort of it unlocks really complex questions, which we're seeing a lot of in practice. So with that, we're going to hop into a demo and see what this looks like in practice. And my goal here is to show that this is not that complicated. And there are a lot of APIs that try to make this really easy. And so we'll see how we can build this sort of complex agentic RAG that plans and reasons and rewrites queries and self-reflects and is connected to a bunch of tools. We can do all of that in 30 lines of code in a notebook. So with that, I'm going to do this very difficult move of changing screens. So here we go, and we're going to open a notebook. All right, you should be seeing a notebook showing some of these advanced RAG techniques. And again, the goal is to show that you can sort of build that in 30, 40 lines of code and unlock some more complex user questions. This has a cost, which is as the model does many hops, the latency gets a bit bigger. But again, models are trained to only to do the minimum number of steps they need to answer the user question. All right, so I was saying there are a lot of APIs to simplify this. At Cohere, we have an API to simplify these advanced RAG systems. I am going to skip the utils, which are just some printing stuff to help us understand what's going on in our RAG system. All right, so the first step here that's interesting is to see how we define tools for the model. So here we're going to equip our RAG system, not with a vector database, but with a search engine from the web and with a Python console. And this is actually pretty straightforward. So the web search engine, we could use Google's API, but it's more fun to use a startup search engine. So we're going to use Tevali. And in 5 lines of code, I have a search engine where it takes a string as input, which is the query that the model wants to make online, and it responds with a whole bunch of web snippets. And now the Python interpreter, which is the second tool we're going to give the model, this is also pretty straightforward. It takes as input the code that the model wants to run. So the RAG system says, I want to run this code. It runs the code and it outputs whatever gets printed to the console. So the model would get the logs from the console to debug itself and to get information about a spreadsheet, for example. And the way we provide those tools to the model is we describe them. So we describe what parameters they take, the type of these parameters, whether the parameters are required. And so the RAG system knows that it has access to a whole bunch of tools. For now, we recommend keeping it to under 10 to 20 tools. And it can, therefore, retrieve from these complex stuff. We're going to equip the model with this CSV spreadsheet, which, again, the model can only really leverage through Python. So we'll see if it can do that. It's a spreadsheet about Spotify songs. So it has a bunch of, every row is a song with the artist, the number of streams, how danceable it is, how much energy the song has, and we are ready to go. So Cohere model, we're going to use a Cohere model to power this agentic RAG. Super simple. We just pick this model, and we're going to try to answer this query. So like, what's the age and citizenship of the artists who had the top 3 most streamed songs on Spotify in 2023? This is a bit complex because it has many different sub-questions. It's sequential. Some of this info is in the spreadsheet, but some of the info isn't. And so we'll see how the model handles this, and more importantly, how what's going on under the hood. So the first thing we can do is we ask the model to plan for this request. So the model will say, look, to answer this question, here's the plan I'm planning to do. We provide the message and the tools, and the model tells us that it's first going to inspect the data set to understand what columns are in the data set. And then it's going to write some Python code to find the most streamed songs and who the artists are. And then it's going to search for their age and citizenships. So that looks like it's going to be a 3-step agent or a 3-step RAG process. And now we just let the model take as many steps as it wants to in order to answer this request. And so this is just a simple for loop where we print the step, we print the plan. That plan may update from iteration to iteration. We print whatever tool calls the model wants to do. So the model might, at every step, is going to suggest some tools. And then we run these tools for the model. So we actually execute these tool calls and provide the tool results to the model so that it can adjust its plan, self-correct, and decide what to do next, calling more tools or answering the question. And so this is what we get. Step 1, the model comes in with a plan, which is the one we went over to, and the first step is to inspect the data set. And so the model suggests making this first tool call, which is called in Python with this code that's super simple that just prints what columns are in the dataset. And so it gets back all these columns with the console outputs, and it moves on to step 2, which is, and again, it updates its plan. So like, given this data set with these, the data set has these columns. I've learned that from the previous step. Now I'm going to write more Python code to find the most streamed songs. And so the model starts writing some code, which is a bit more complex and is actually accurate because the model knows what columns are in the data set now that it has looked them up. And so the model gets some information about what the top 3 songs are. And again, step 3, it still cannot answer the question. So it continues calling more tools. So this time it says, look, I know what the top 3 songs are, but I need to search for the age and citizenships of the artists. And so this gets interesting because the model says, look, now we're going to make parallel queries. And the model creates all these parallel queries, so 5 web searches in parallel to get information from on these different artists. And then, so this is great. This is exactly what a human would do. And now you get these tool results, which are all the results from the web searches. And now the model, after step 3, decides that it has enough information and it can answer by saying, look, these were the top stream songs. These are the artists. This is their age and their citizenship. And so with that, we sort of saw how in a pretty simple notebook, we were able to get started with this agentic RAG, and we were able to answer some pretty complex queries. So now I'm going to give it back to Ayush. This was sort of a prototype, a notebook. It is not instrumented. It is not evaluated. And I am going to give it to Ayush, who is going to walk us through best practices to instrument and evaluate these kinds of RAG systems.
Thanks, Maxime. That was really lovely. We have a lot of nice questions. I guess we will be touching upon them once I'm done with my session. Yeah, we'll definitely try to keep time for taking up all the questions. Right. So Maxime talked about this agentic workflow and ways to improve a simple RAG pipeline for like a complex query, right? In my presentation, I'm gonna be building upon his work. First, there's gonna be 2 parts. One, I'm gonna be talking about how we should think about doing it in a correct way with like proper tooling. And there I will be introducing a tool called Weights Basis Weave. It's a very lightweight tool, so would love to demo that quickly, and then we'll go into 3 simple evaluation strategies for an agentic workflow that Maxime showed. Right? Yeah. So first of all, just I want to set some ground rules. All the LLM applications that we talk about, or we demo, or we discuss are very niche, right? What I am building might not be what you are building. Every application involves decisions to be taken about what frameworks you're going to be using, what amount of money you are going to be spending, right? So all of these different factors are going to be motivating or going to be guiding you towards building an application. So the most we can do here is share ideas, right? And try to solve business problems here. Another pointer that I want to outline is that LLM application building is not conventional software development, right? There are many moving pieces which are not deterministic in nature. So evaluation is a really important thing. And another important thing is that a lot of these frameworks, even the LLM vendor, like for example, Cohere has a version today. It might be outdated tomorrow. And the system needs to adapt to the changes in the LLM, because the capabilities will improve. You might require to reduce that complexity of your pipeline. You might see that now function calling is working really well, which was not the case maybe 5 months back. So yeah, like the application itself needs to keep changing quickly. So we need better tooling around the space to guide us through the whole process. And then finally, the iteration cycles are also weird here. Like again, your like that, because your application is your application, your iteration cycle is also going to be your iteration cycle. It's not like a simple machine learning iteration cycle where you start with some data, you train some model, evaluate on some benchmark, and you have a feedback mechanism from that way. Here you have the application evolving with the LLM, with the ecosystem around that LLM, plus your evaluation is going to be evolving as well. Your user base feedback is going to be evolving as well with more usage of your application here. So there are a few interesting changes that happen over conventional software development that needs to be tackled with specific tooling in the space. Two quick, like two common applications that we see of LLM, like two common LLM applications that we see in the space are RAG and agentic. And the agentic workflow that Maxime showed was like one step above RAG. Like it has a multi-hop way of like you plan, you make use of some tools, then you see if it can give you the answer or not. You plan again and so on and so forth till you have an answer that is sufficient. But with a simple RAG, it's like, and for a lot many use case, a RAG itself is good enough. You have a vector database that you create out of the documentation or out of the documents you have, which are private to you, which an LLM might not have any idea about. And then basically a user asks a query, you retrieve some information from the database, send everything to an LLM and generate a response, right? This is something we all know. I think we all have built this, but a RAG is as good as the retrieval system. So the quality of the retrieve context is going to be determining the quality of the response. So we need to evaluate the retrieval cycle. We need to evaluate the quality of the response. And we also need to see what models are working best for a given use case. Right. Next up, Maxime showed this nice agentic workflow. I just happen to have a definition or have an understanding of what an LLM-based agentic workflow looks like. For those who do not have a background in machine learning, for example, might think that agentic workflow is a new term and a new thing, but actually it's based in rich literature. There's this whole huge reinforcement learning is a part of it. There's this whole literature on how to build an agentic workflow. It's just that LLMs now are a very strong policy. So policy is something which can come up with plans and plans which will determine which actions to be taken. So LLMs are really powerful that way. We still have an action space wherein the LLM has access to these tools, and it can use the tool to gather more information, which will help guide the planning process ahead. And yeah, like in my environment can be that loosely formed. It can be loosely said like a final response that's been generated, or maybe few intermediate responses that are generated by the workflow. So that's the environment. And then feedback usually in practice is the chat history that we are giving back to the LLM, right? So we can do a lot with the chat history. Maybe we dump everything that we gathered so far at a step T maybe, or we can do some clever like summarization or something fancy to reduce the context length of the chat history. But that's what the feedback we give back to the agent to maybe plan again and go from there, right? So this is me trying to map Maxime's workflow with kind of a formal definition of what an agentic workflow is. So to summarize, building prototype is really easy. Maxime showed that, hey, you can build a simple agentic workflow in few lines of code that can tackle complex queries, right? You cannot tackle those complex queries with simple RAG. You need a planning and use of tools there, right? So it's very easy to prototype, but it's still very hard to productionize such a workflow. The reason being, today, like in the past, when we were mostly concerned about training models, we were concerned with the architecture and the artifacts connected to that, maybe the checkpoints, the weights that we save, etc. But now it's more about the composition of functions, the API calls that we're making, and the configuration controlling the entire application in a sense, right? So that's what the model is today for us. Earlier, the data sets were huge, right? We used to save these data sets with maybe WAN-DB artifacts or on Google Drive, whatnot, and you used to version that. But now these data sets are very small. They are usually human generated and rapidly evolving. Earlier, when we created maybe an ImageNet data set, that was static for a very long time. It's not like we created an ImageNet today and we created a V1 or a V2 tomorrow or day after tomorrow, right? But application development requires rapid iteration of the data set itself, be it the and most like be it the data set that you require to make that workflow operational, or data set that you require to evaluate the system. So yeah, like we have moved from tracking the losses, the loss curves, to tracking the number of interactions we are doing with the LLM, the number of calls we are making, the number of tools we are using, right? Because all those things contribute to the latency of your system, and we want to optimize for that. We want to reduce the number of tool calls happening. We want to reduce the number of LLM calls happening, because that's hitting an API. It takes some time to process it, right? So we want to reduce that. So that's what we need to track today. So just to summarize, every activity that's happening in an LLM workflow or an LLM application needs to be tracked properly, and that's where WAN-DB Weave comes in. If you are someone who have used weights and biases in the past from the like our line of products on the models family, be it experiment tracking or sweeps for hyperparameter optimization, you might for those workflows, our product lineup is really well catered. But because we are seeing this new trend in folks just using the LLM itself and building applications, Weave itself is a standalone product that we have that you can use to trace everything as well as evaluate. And just to give a formal definition here, this Weave is a very light toolkit that you can use for tracking and evaluating. And I will show that in the demo how light it is, because my demo is literally based on top of Maxime's work with some evaluation. Yeah, and just to summarize, the core capabilities of Weave are to, one, trace the entire timeline of events that's happening. We can also use Weave for versioning data sets and versioning the models. And models here doesn't mean the weights in .h5 format or the checkpoint format, but it's literally a class which contains all the parameters, be it the name of the model, number of steps to be taken, the temperature of the model, etc. Like those parameters with all the different function calls or tool calls that happens. The compose stuff is called model here, and then we use this as well for evaluation. Having said that, here's the collab link. I will be sharing this afterward, maybe over email as well. But if you're interested, if you want to follow, you just type in wandb.me/agentic-eval-cohere. With that, let me hop over to the collab notebook and start talking. Yeah, on how to use Weave and how to go about evaluating the system. Yeah, so as I said, it's literally based on top of Maxime's work, and this is pre-run, so I will not be running the whole thing again just to save time. But yeah, it's the same Weave and other stuff that we are installing Cohere and we're installing Weave. This is the other package that will give us access to using Weave. We import Weave, and the utils remain the same. All the fancy print function that Maxime wrote for us to understand what's happening properly. This is the web search. This is one of the tools that he showed. Just notice this decoration using weave.op. So Maxime showed the usage of web search. All I'm doing is wrapping this function with weave.op, and I will show what it does. But formally, it tracks your input, the query, and the response that is generated from this function or processed from this function. So we are able, by doing this, if we decorate all the functions with weave.op in our LLM application, we can literally track the input and the output and how they are connected together. So this is web search. I also decorated the Python interpreter. This is the console that Maxime was talking about with weave.op. Nothing so far, just imported Weave and decorated the two tools with weave.op. Great. Let me actually zoom a bit more. Not visible. Yeah. Next up, we will be using the Cohere model, and because we've want to track everything that's happening within that LLM call, all the information that was sent to the Cohere API and everything that was retrieved from the API, we will be, like we have an integration with that, and this is all we are doing. We are just calling the integration so that we can look at the underlying stuff that's happening when we do an LLM call. And I will show what it looks like. Yeah, we created a Cohere client, and final step is we initialize a Weave run. So we do this. If you have used OneDB, you do OneDB.init. Because we're using Weave here, we just do Weave.init. As you have seen, we are not using OneDB at all. It's just a standalone product for LLM application use case, right? So Weave.init, we got the project page, great, all got, put in your OneDB API key, and you have the stuff. So the first thing we did is that Maxime showed was we used one LLM call to create the plan. Yeah. So for a given query, and the query here is what's the age and citizenship of the artist? It came up with a plan. Earlier we saw the plan in the as a std out. Now when I click on this link, it takes me to the Weave workspace where I see the trace cohere.client.chat. Yeah. So we see all the inputs. So input here is the message, the model which was used, the system prompt or the preamble, and we also have the list of the tools. So this tool is the web search tool. This tool is execute a Python code. So it's a Python interpreter, right? And then we get some output. The output here is I will first check the data set to see if it contains information about the top 3 stream songs, right? And then it also generates a piece of code which we can send to the Python interpreter function. This is what it came up with, right? So this is the first step. As you can see, we are able to track all the inputs and the outputs from this API call. A few extra things that we are tracking off the shelf is the number of input tokens you use, or number of output tokens that were used, right? And the version, the number of tokens that were used, etc. So this is something you get off the shelf just by adding few lines of code to your application. Great. So this is the first step. We created a plan. The next step is we run this workflow, this agentic workflow in a loop fashion, which Maxime showed. And as you can see, it created a few steps with some URLs here. So all these URLs are individual Weavified function that was executed, right? So you might not like it that, hey, there are so many links that I want to track and gets messy. That is true. And I want to just show how it looks like. So this is the first Cohere call that was made, which did the planning. I will first check the data set to see if it contains information or not. Then, as I showed, it created this Python code like this here, and I can actually change this to maybe code for better readability. Yeah, import pandas with this CSV file and then do some stuff. It sent this code to Python interpreter, and it returned me some output here. The executed code was this, and yeah, there was an error. When I ran this, I unfortunately didn't add the Spotify dataset or CSV file to it. That's why the next call, the Cohere call, said that, hey, the dataset does not contain information, so I need to do web search, right? So it looked at the query, it created a query for the web search, top 3 most streamed songs on Spotify, and you can see that it did a web search, and actually us doing the web search by using the query that was generated by the LLM, and it came up with, okay, this is the title, this is the URL, this is the content, which it was returned by the web API that we used, right? And it, as you can see, started with a plan, did some web search, again called the Cohere, did a few more web search to finally have the answer generated, which is the top 3 most streamed songs are this, and we have the age of all the artists and their nationality, which is great. But again, this is all scattered, right? A better way to write this agentic workflow is to you use something called Weave.model. So Weave.model is basically a simple way of writing like a combination of data and the API call and everything in a single class. This weave.model under the hood is basically a pedantic base model. So you write the whole thing in a pedantic style, and it's actually great when you're writing good software because you have strong type linting, you have strong validation that you get out of the box if you're using pedantic. And if you use weave.model, you get versioning of this particular agent off the shelf. You get the tracking of all the important parameters off the shelf, right? Let me show executing this. So yeah, we basically wrote this class inherited from weave.model. All the methods inside are all decorated with weave.op, right? Right. So initialize this class with the system prompt or preamble, gave it the same tool. It's the same thing. It's the same piece of code that Maxime was demoing. I just wrapped it in this cool class just for better readability and better version management and whatnot. And we ran this on the same prompt. What's the age and citizenship of the artist who had the top 3 stream songs, right? So as you can see, we just have the steps 1, step 2, step 3. We do not have extra lines of the Weave URL because everything now is literally in this one Weave model stuff. This is vsimple Spotify agent v8, right? This is the class that you are seeing here. Where is it? One sec. Yeah, the simple Spotify. And if I just click on this, maybe just to show what you get off the shelf, you see all the methods are versioned as well. And if I click on this version, for example, I can literally diff between a V1 of this version and V2. So V1, I just changed the couldn't to could not. I don't know why I did that, but and if I looked at V0 and compare with V2, there are a few more changes. So I was in V0 adding all the tool results in this list and returning that list as well, which I later thought that it is not useful. So yeah, like you get all of this out of the box, right? Because you just wrote a better piece of code with weave.op, with weave.model, right? And you can see the whole trace timeline. So this entire trace timeline where you ran a function, invoked a method and it then did a client, like LLM call, did a Python, ran this Python interpreter tool and did some web search to finally have the answer. This is great, right? It's already looking like we built a simple agent. And you can imagine that in a complex workflow, there can be multiple agents, and all these agents can be their individual weave.model, and they all can interact with each other, and it just makes the whole code base easier, and you track everything out of the box, right? Another key point that I want to highlight here regarding in the context of evaluation is that the entire trace that you are seeing can be considered a trajectory. So what's a trajectory? Trajectory is basically the whole, the sequence of events that happen. Trajectory is a word coming from RL, but yeah, that's what trajectory is. I will now quickly talk about evaluation. So we have this nice prompt, nice agent here. I also ran this agent on another question: what's the most danceable song on Spotify? And when it ran this agent, it literally went through multiple loops, step 4, step 5, step 6, till it exhausted the maximum number of steps it has to take, and does return max step reached, the code did not work as expected. So it just got in the loop of not being able to fix the code. And I guess, yeah, this is the trace timeline. You can see it created a plan, did a tool usage, tried to fix the code. I guess the issue with the code was, f string unmatched. Yeah, there was some issue in the code that it came up with, and it kept doing it till it reached the maximum number of steps. Right. So this is one way you can try to limit prevent the infinite loop, right? And maybe you can then go in and try to see what in the prompt you can tweak to maybe prevent your agent to not get stuck in a loop like this. Yeah. So on the evaluation side, you can do literally a lot of things here, right? And one should literally consider evaluating an agentic flow really well. We should make sure to, we obviously need to evaluate the final response that the system is creating. And ideally, it would be nice if we can compare this ideal response with a ground truth to see how far off it is. We should also be able to ground the generation of the response on the context that it is gathering, right? In a simple RAG pipeline, we give the context via using a vector DB. In this case, the context is generated via some database, like via querying some database using some Python code or doing some web search, right? So the the the, the context here is not something which is set on stone, right? So we need to evaluate, see how grounded my response is to the content. And yeah, we can do some simple evaluations like how good is the function calling happening? Like you can evaluate the function calling itself. You can evaluate if the LLM is coming up with the right name of the function. In case if you have 100 of tools, right? Is it coming with the right tool for a given scenario? You can do all that thing. Yeah, so this is the data set that we have for the Spotify data set. The first step for evaluating end-to-end, which is to evaluate the end result or the response with some ground truth, is to come up with a data set. So what I did was literally thought of few queries like which song is the most danceable song, which song has the most number of artists collaborating, how many songs did Taylor Swift release in the last 5 years, right? And the ground truth was me writing few lines of like a line of pandas code to come up with the ground truth answer because it is based off the data set here. And yeah, so I'm making two assumptions. One, all these questions can be answered just by using the Python interpreter tool. You do not need to do web search. So in the trajectory or in the trace timeline, you should not see any web search, right? If that's happening, then there's something wrong. That's the tool is the LLM is not coming up with right code, or even if it's coming with right code, there's something wrong with the data set, right? So that's one assumption. The second assumption is that I'm not expecting the ground truth to be a structured format, right? It's just a right word or the right combination of words, which is the right answer. But the LLM can give me a long form response that the most danceable song of Spotify in 2023 is this by this artist. That's totally fine. That's the assumption, right? So what I did was created this data set, wrote few lines of code to create this correctness evaluator. This is an LLM judge or an LLM evaluating the system. So this is under the hood using command R. It has a system prompt. You're responsible to evaluate the response of a system against some ground truth, right? And I'm expecting it to come up with this response, this decent format response, right? And then I give it. So I then have this scorer function. So I can have as many scoring functions as I need for my use case. Wrapped everything with evaluation, gave it a name response evaluation, gave it the data set that I created previously, and then gave it the scoring function, this LLM as a judge, and ran it on the system. The simple Spotify agent ran this. So what's happening under the hood? It's literally taking individual samples from the eval set, giving the query to the simple Spotify agent. That agent is running the whole thing, returning the response back to this to the scorer or the correctness evaluator, and then it's literally asking LLM to, hey, this is the ground truth, this is the generated response. Now give me your judgment here, right? And I ran it on those three examples, and I got a 66% accuracy, right? At this point, just want to point out that this number may not be that significant because I just have three examples. Ideally, you should have many more examples to make this statistically more relevant. But yeah, let me just quickly show the eval. So this is the evaluation page. You can click on the evaluation tab here and see here. So I ran two evaluations. One evaluation gave me a score of 100%. Other evaluation gave me a score of 66%. What happened? Let me go in this. Click on this, and then I click on the table. So I can drill down individual examples or the evaluation of the individual examples. And I see that this was wrong as per the judge or the LLM judge. The ground truth is this, and the model's output is most danceable song on Spotify is this, right? But I can see the ground truth in the response as well. In my opinion, this should be correct, marked as true, but the judge said it's not true. And let's see why that is the case. Turned out the reasoning for the judge is that The ground truth only mentions the song title without any details about its danceability or artist, right? So it literally said that thought that the ground truth is only the title and has nothing to do with other information like the name of the artist, right? Because there's a name of the artist, it gave it a false score. So this is a point where we'll go back and fix the prompt of the judge to align it with my preferences, right? So this is literally human like alignment of the judge. I do this by modifying the prompt, and I do this by adding few short examples to this, right? The last bit that I'm going to talk about is you can, because everything is logged to Weave, I can literally get the entire trace or trajectory, and I can get all of that. So the trajectory here is like the whole thing, the whole sequence of events. I can literally get all the sequence of events. I wrote a piece of simple code. It's a recursive thing, and which gives me the trace or the trajectory like this, where this is the depth and this is the name of the op, right? So a depth2 means that it's nested within simple Spotify agent, right? Ran the whole trajectory, got the whole trajectory. Now I wrote two simple functions, the exact match and the Levestin distance, right? So exact match is literally comparing the both trajectories and saying that, hey, both the trajectories are same. Levestin distance is a bit more fancy. It's looking at it's more about the similarity of the trajectory and more than the exact matching of the of the trajectories, right? So the question might be, hey, where is the ground truth trajectory? Now, if you remember, there was a run that I did which gave me 100% accuracy. Now, you can either create a trajectory manually if you know about your domain and what is a preferable trajectory, or you run some agents and see which agents is giving you a satisfactory response and use the trajectories of the response as a viable like ground truth trajectory, and see like try on queries that might be slightly different from the for the query that created that trajectory, right? And I ran this, giving a 100% score, which is fine. It's a very toy example, right? And the final thing is you can also ground it because you have access to all the trajectories. The final trajectory was the LLM creating the response. You can go in and maybe collect all the results that were derived from the tools and see if the final response was grounded on the truth, on the context or the content, right? And this is like factfulness evaluation. So you check how factful is your answer that was generated, and there also you can write a simple judge, just like I wrote for the correctness. I have written it here, but I don't think we have enough time to run it over. But yeah, it's a simple concept. You collect all the outputs, and then you basically ask an LLM, hey, this is the context, this was the generated answer, how grounded is the generated answer, give me a score, right? And you can see, and it gave me a score of 100%, but as you add on more samples to the eval set, it's gonna be more statistically relevant. Yeah, and this is the code, you can check it out. And yeah, I just wanna again point out that yeah, we are launching this course very soon. You can, if you want, you can pre-register from this link. We are also giving some free credits to run the whole course, so you might be interested. Yeah, I guess we are about time, but Catherine, if we can take maybe a question or two. Yeah.
I've been trying to go through some of the questions in the chat during the presentation. Ayush, do you see a question about what you just presented that you want to take?
Yeah, I just want to take one question, which is I'm unclear on what you mean by trajectory. My meaning of trajectory here is very simple. Your LLM agent, or the agentic workflow, is literally using LLM to come up with some plan. It's then making some function call, so on and so forth. So there are multiple events that are happening one after another, either sequentially or maybe few parallelly. The whole sequence of events is what I'm calling trajectory here. So you want to optimize for the trajectory, like, because if it goes on forever, it's gonna take a lot of time. The latency is gonna be very high. So you want to optimize to reduce the number of steps it takes. So yeah, that's what I mean by trajectory. Yeah, Maxime, any interesting question you want to take?
Yeah, one question. So I tried to go. I think the chat will be available in the recording. So I try to answer them there. One theme of questions in the chat is, hey, for RAG, I'm trying this technique or this technique. Which one is better, or which one should I do? And the answer here is, unfortunately, there's no like magic bullet of like this is better than that, or this kind of RAG is better than this other kind of RAG. And really, the only way to sort of navigate this is to evaluate. And so start with a simple recommendation is to start with a simple setting, and evaluate it on, and so there are a few strategies to evaluate, but basically evaluate it on some representative queries that you're expecting to see in production, potentially even production queries, and then navigating based on that. And there is no like this is better than that. It is really dependent on your use case, and evaluating and all the tweaks you could do to these architectures is how you make sure you make progress and you go in the right direction for your use case.
Yeah, just to add on that quickly, don't go into thinking about using fine tuning a model or using an don't go into all those fancy stuff. Just start with a simple prototype and see what's working, what's not working. Ideally, use a frontier model like Cohere or some other LLM which is like ahead in the curve, and yeah, use simple techniques and then build some evaluation, and then let the evaluation guide you while developing your application as you make more complex stuff, add more complex stuff to it. Yeah. I think having said that, we can wrap up the event. Thanks, Maxime, for giving us the time and working on this nice agentic workflow and the whole thing. Yeah, I hope folks were able to pick on few ideas, and yeah, we will be sharing the recording, and we will be trying to. If you have more questions and if you want some like answers to those, we can maybe reach out to us over Twitter or maybe email us or whatnot. Yeah. We will share and also we will be sharing all the resources with you all soon. Awesome.
Thank you. See you.